Stages of tooth development. We have the physiological phases and morphological phases. The physiological phases of tooth development are on the basis of physiological processes that take place in the tooth germ. These processes are initiation, proliferation, histo differentiation, morphodifferentiation, and apposition. Okay, of all these physiological phases, except initiation, the rest of these four phases can overlap with one another. For example, when proliferation is going on, then histodifferentiation can start at the same time. Similarly, when histodifferentiation is going on, this morphodifferentiation can also begin. The morphological phases or stages of tooth development, they do not overlap with one another. So when one stage is completely ended, only then the next stage will start. Such as when the bud stage is going on, this cap stage cannot begin. When cap stage is going on, this bell stage cannot begin. So when the bud stage is completely ended, then comes the cap stage. When cap stage completely ends, only then the bell stage starts. The physiological phases, they can overlap with the morphological phases. Proliferation, histodifferentiation, and morphodifferentiation, which are the physiological phases of tooth development, they occur at the same time in early bell stage, which is the morphological phase of the tooth development. So tooth germ in early bell stage is undergoing multiple physiological stages at the same time. Initiation, it marks the beginning of the tooth development. It is the shortest of all the phases and the first evidence of tooth development, it appears in 6th week of intrauterine life with development of dental lamina. This dental lamina is basically a lingual subdivision or a horseshoe shaped lingual extension of the primary epithelial band of oral ectoderm. This oral ectoderm is basically the oral epithelium, which is stratified squamous epithelium. Okay, this is the oral ectoderm. Oral ectoderm or the oral epithelium. This part of the diagram shows dental lamina. Okay, this is the epithelium, dental lamina, and this part is the ectomesenchyme or the connective tissue, whereas these purple dots here is basically the condensation of ectomesenchyme or the connective tissue. The condensed ectomesenchymal cells, they induce the overlying epithelium to start dividing or to proliferate to mark the beginning of the tooth development. The importance of initiation phase of tooth development is that it decides the further commencement of the tooth formation, the number of teeth to be formed, and location of teeth in the dental arches. With the end of initiation phase, the proliferation begins. Proliferation, it begins at the bud stage, continues through the cap stage, bell stage, and then it ends at the advanced bell stage of the tooth development. Okay, proliferation is the longest phase of all the phases of tooth development. It is basically increase in number of cells. Let's say these are different cells. So when they divide, there is an increase in their number. And as a result of this increase in number of cells or proliferation, there is an increase in size of tooth enamel organ. So as mentioned earlier, that proliferation, it causes increase in the size of enamel organ, as you guys can see in this picture. There is an increase in size of the enamel organ. Now this increase in size is because of the division of the cells, or because of increase in number of cells. This division of cell stops, and this increasing size of the enamel organ stops when there is a differentiation of ameloblast and enameloblast. Now these ameloblast and enameloblast, they do not have the property of cell division. As a result, when the cells are differentiated, the division of cells stops and enamel organ stops increasing in size. Okay, so importance of proliferation in tooth development is that it determines the shape of crown, and it provides adequate cells for further development of the tooth. Okay, in case of any defect in the proliferation, there will be failure of tooth germ, to develop, and as a result there will be decrease in number of teeth. Whereas excessive proliferation can lead to the formation of epithelial rest cells, which can either remain inactive or, when activated, can result in the formation of tumors or cysts. Histo differentiation is a physiological process in which immature cells, they undergo morphological and functional changes to perform their function. So basically, immature cells become mature and ready to perform its functions. Now, this histo differentiation, it begins in gap stage and it is maximum in the bell stage. Okay, for example, inner enamel epithelium, it differentiates into ameloblasts, and these ameloblasts then deposit enamel. Here, this is enamel organ. These are the inner enamel epithelium cells. Now they start as cuboidal cells into differentiates into short columnar, from short columnar into columnar cells, from columnar cells into tall columnar. Then there is reversal of polarity. As you can see this transition, there is a reversal of polarity. It will be discussed in detail later on. Then there is formation of Tome's process. And these cuboidal cells maturing into tall columnar cells and eventually developing Tome's process, maturing into a fully differentiated ameloblast. So this is the shape, or this is how the fully differentiated ameloblast looks like. Okay, this is the enamel organ in bud stage, and these are the central cells. In bud stage, these central cells differentiate into star-like. These are the star-like stellate reticulum cells. This diagram shows enamel organ in the early bell stage. So in early bell stage, stratum intermedium cells develop, and dental papilla cells differentiates into odontoblasts, and these odontoblasts deposit dentine. So these were the different examples of differentiation or histodifferentiation of different cells. Okay, defect in the histodifferentiation of ameloblast will result in amelogenesis imperfecta, and defect in the histodifferentiation of odontoblast will result in dentinogenesis imperfecta. Okay, morphodifferentiation is the change in shape of enamel organ to attain the shape of the tooth to be formed. So morphodifferentiation basically determines the shape of tooth that is to be formed. So overall morphology of the tooth is determined in the morphodifferentiation stage. So morphodifferentiation, it begins at cap stage, at which the inner enamel epithelial cells, they start attaining the shape of crown to be formed. Okay, these diagrams, they shows the shape which is attained by this inner enamel epithelium. So this shape will be basically will determine the shape of the tooth to be developed. For example, this is the enamel organ of canine. This is the enamel organ of incisor, premolar and molar. So when this shape is attained, then these enamel organs will increase in size, such as, let's say, this is increasing size. So overall what happens, that this enamel, the inner enamel epithelium, it attains the shape of the crowns of different teeth, and then this enamel organ will eventually increase in size to attain the desired size and shape of the tooth. Okay, any disturbance in the morphodifferentiation will result in abnormal size and shape of the tooth, such as macrodontia, in which the teeth are developed in size larger or size greater than the normal size of the tooth. The microdontia, in which teeth developed are smaller in size than the normal size of the tooth. And then there is the peg lateral. Okay, a position is the rhythmic deposition of dental hard tissues, in which ameloblast and odontoblasts will deposit enamel and dentine, but in a rhythmic process. Like there are periods of rest and activity which results in the formation of incremental lines of dentine and enamel. This diagram shows enamel organ, and these are the ameloblasts. So ameloblasts deposit enamel in a rhythmic fashion, and these are odontoblasts. So odontoblasts then deposit dentine, and this is pulp. And this activity of deposition of the both enamel and dentine occurs in the apposition stage.